Hi guys, myself Ankit. In this video we shall see another problem on LeetCode. Kth missing positive number. So given an array of positive integers sorted in strictly increasing order, an integer k. So return the kth positive integer that is missing from this array. So the question is, you could see the given example here, 2, 3, 4, 7, 11. So if you see, they say it's a array of positive integer and it's strictly in the increasing order. So that means they have given k equal to 5. If you see the numbers from 1 to 11, let me write the numbers 1, 2, 3, 4. Here are the numbers from 1 to 11. So if you see 1 is present in the array, no. So the first missing integer will be 1. Next, if you check 2 is present, 3 is present, 4 is present, 5, 6 are not present. Again 2 missing integer. So here 1 is not present, 5 is not present. So this will be the first missing integer, second missing integer, third missing integer. Then coming to 7, yes, it is present in the array. 8, no, it is not present. So this is the fourth missing integer. Then 9, even this is also not present in there. And here comes the fifth missing integer that is present in the array. So you have to return the answer 9. The fifth missing integer in the array, the given array is 9. So what is the approach to solve the problem? So normal brute force approach you can do where you linearly compare the elements if one is present. Then if it is not present, then just increment the count to 1. Then check for 2 is present in the array. Yes, it is. 3, 4. So keep a pointer for both the numbers. So and you can keep on incrementing the values. But here what we will do is we will use the binary search method. As they have told in the question that it's a array and that the elements are in the sorted order and it is in the increasing order. So here we will see how can we apply the binary search method here. So as you all know, in binary search method we will have a two pointers. So one is pointing to the low, other is pointing to the high. Fine. And I'll mark the index. Low means it's not pointing to the element, it's pointing to the particular index. So this is 0, 1, 2, 3, 4. So the corresponding index, low equal to 0, high equal to 4 we have initially. And we have to compute the mid. So what is mid? 0 plus 4 by 2 will be 2, so it will point here, second index. So now we have to, what we will do is, we will check whether this index, how many missing elements are present. So that means, as I said before, here the array, if you take into consideration the actual elements that should be present in the array is nothing but um, here it should be 1, okay, 1, 2, 3, 4, 5. This should be the array actually, but we have some elements missing the array and that gave us this resultant array. And how do we find what is the number of missing elements for this particular index? So if you check 4 minus 2 plus 1, if you do it, basically 4 minus 3 we are doing. So 2 plus 1 if you do, that will give you 1. So for this index mid equal to 2, one element is missing in the array. Of course, as it is right because 1 is missing in the array, 2, 3, 4 are present. So one element is missing in the array. So if instead of 4, let's say I had a 5 as a number, right? So 5 minus 3, 5 minus 2 plus 1, 5 minus 3. So that was equal to 2. Are two elements missing in the array at this position? Yes, it is. 1, 2 is 3 and present, 4 is not present. So 1 and 4 are missing in the array before the mid. And at this index, we have come to know that two numbers are missing in the array. And we want to know fifth missing positive integer. So two positive integers are missing in the array, we have come to know. But we need fifth positive integer. So what we can think of is, we can just increment the, I'll rewrite it to 4 only because in the given question they have given this example. So for this example now, why am I doing 2 plus 1? Because indexing is starting from 0. So if you just increment the value by 1, you will get the particular integer that should be present at this index. So that's why I'm just incrementing 2 plus 1. So nothing much in that. Since the indexing is starting from 0, I'm just incrementing the value from 1. If it was starting from 1 itself, then there was no problem. Directly we'll get the 3 as the answer. But we have the index starting from 0. So if we do 2 plus 1, that is 3. So 3 must be the actual integer that should be present in this index, but we have 4, so 4 minus 3 will be 1, that means 1 is missing. One, not 1 is missing, one element, no, 1 integer is missing in the array previous to this mid. So as I said, if there was 5, 5 minus will be 2. So 2 numbers were missing in the array. 1 and 4 would have been missing in the array. So we have this 4 minus 3 equal to 1. So let's say a variable called missing, okay, and we will initialize it to 4 minus 3. So that will be 1. So this is the missing number of missing elements at this index mid. So but what we need to have, we want kth missing integer, but we have first missing integer at this index. So what can we do? We can just, that means the missing element more than one will appear after mid. So that's why what we will do is we will make low equal to mid plus 1. So this is low. Okay. So this is low. And here we have high. Again we will compute the mid. So what is mid here? 3 plus 4 by 2 will be 7, 7 by 2 will be approximately 3. So my mid is pointing at this position. So now check 4 minus 3 plus 1. That is the missing number. What it is? 7 minus 4 will be 7 minus 3 plus 1. Yeah. So 7 minus 4 will be 3. So that means what this 3 means, at this index, particular index 3 position, 3 elements are missing in there. Is it correct? 1 is not present, so 1 is the count. 2, 3, 4, okay. 5, 6 are not present, so there is 2 more integers not present in the array. So 1, 5, 6 are not present in the array before the mid. That's why we can show that 3 elements are missing in the array. So 7 minus 4 will give you 3. So is 3 again less than 5? So what can we do? Just increment the low. Yes, 3 is less than 5. So that means the number appearing will be after mid. So again we will do low equal to mid plus 1. So low will point here. So now mid will be pointing to this position only because 4 plus 4 by 2 will be 4. So again mid is pointing same position. So at this point, how many elements are missing in the array? Let's check that. So 11 is the element present, but the actual element in the present should be 5. So 11 minus 5. So how do I get this 5? That is nothing but the particular index plus 1. So 11 minus 4 plus 1. So that will be nothing but 6. So at this position, 6 elements are missing in the array. So is it correct? So 1 is not missing. Then 2, 3, 4, 5, 6, then 7, okay, 8 is missing, 9 is missing, 10 is missing. So 1, 2, 3, 4, 5, 6. Yes, it is correct. Total 6 elements are missing in this array at the position where mid is pointing. So that means now we have 6 that is missing in the array and that is greater than 5. So at this point, what we will do? If it is greater than 5, what we will do? We will do high equal to mid minus 1. So, okay. So low will point here only and high will be mid minus 1. So it will move here. So now low and high have been crossed. So this is the basic binary search algorithm I have applied. I hope you guys know that. Now low have crossed the high, so we can stop the loop. So but have you got the missing number now? Kth missing integer, fifth missing integer? No. So how do you fetch the missing integer from the given positions of high and low in the array? So if you observe carefully, as I said, high is pointing here and that is marking at the position 3. So but the actual number that should be present at this position is 4. So that is nothing but 3 plus 1. So if you see, it's nothing but high plus 1. Correct? The number that should be present at this position is 4. How do you get the 4? That is nothing but high plus 1. So 3 plus 1 will give you 4. So once you have this 4, so from 4 to 5, 4 from 4, how many elements are missing? Fifth element we need. So that is 4 plus 5, that will give you 9. So whatever is nothing but high plus 1 plus the given number. That will give you 9 as the answer. So it's basically nothing but you are checking what element that should be present at this position. That is nothing but the given index. So high index plus 1. So 4 should be actual present in position. From there, fifth element you have to trace. So 4 plus 5, that will be 9. So this is the answer for the question. So we shall program this now. So first I'll write up the size. So array size. So next we have low, that is pointing to 0th index, and we have high, that is pointing to last index in the array. So next, start with the binary search. While low lesser than or equal to high, first we need to compute the mid. So it mid equal to low plus high by 2. So after you compute the mid, the next thing which you will be computing is the missing number. So what is the missing number? This particular element minus index plus 1. Why index plus 1? Since the indexing is starting from 0, index plus 1 will give you the actual element that should be present in this index. So that's why we'll have an int missing equal to array of mid, okay, that particular mid minus index, that is mid plus 1. So that is the kth missing number at this particular position. So now check if missing is less than k, then just low will be equal to mid plus 1, okay, else high will be equal to mid minus 1. So after this, at last you have to return high plus 1 plus k. So as you see, high is the position. So 3 plus 1 will be 4 is the actual element that should be present at this position. From there, fifth integer we are looking for. So we shall run this. Yeah, and for Java also it's the same code, only instead of here size, you have to give array length. Then everything remains the same. Yeah. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with the other one in next session. Until then, keep learning. Thank you.